Hello everyone, this is lecture 14 and this is gonna be our last lecture in part 2 which in other circumstances I would tell you that this materials is enough for midterm 2. So today we're gonna be talking about lecture 14 which is about linear approximations. So here is our usual graph, the same graph that I use in all of the lecture, which represent the function f of x, and here is the tangent line that is drawn at the point A. So if I wanted to write the equation of this tangent line, the pink one, y equal L of x, and we will understand why we call it L of x. L goes for the linearization. If I just want to write the formula of it, it's gonna be y minus y1, and y1 here is f of a, equals m, which is the slope, x minus x1, which is the point A. And then I will rearrange my equation, and instead of using m, I will use f dash of a. This is what we have learned. So it's gonna be y equals f of a plus f dash of a x minus a. And then I'm gonna say that this y is the linear approximation of x. So I will call it L of x equals y, or equals f of a plus f dash of a x minus a. So what did we do? What we did is that I am simply saying that if I want to approximate the value of y at this point, I can just say that it is very, very close to the value of y of the tangent line at this same point. So the function L is represented by the tangent line at x equals a, and L approximates f near a. This is the same understanding of the limit that we have taken before. So if x is approximately equals a, then f of x, or y, is approximately equal L of x. Let's take an example. I'm having a function f of x equals root x, and then he's telling me find the equation of the tangent line to this graph at x equals 4. Okay, equation of tangent line, so y minus y1 equal mx minus x1. And to have this equation, I need three unknowns. I need a value for x, I need a value for y, and I need a value for the derivative, or the slope. X is 4. If I substitute 4, I can get y square root of 4, so y is equal to 2, and then I can have my equation. So we now know that x equals 4, y equals 2, so the equation of the tangent line will be y minus y1 equal m. M is the derivative, x minus x1. So m will be half x power negative half, and I did substitute, and I knew now that m equals 1 over 4. Therefore, substituting back to equation 1, y minus 2 would be equal to 1 over 4 x minus 4. So y equals 2 plus 1 over 4 x minus 4. So part B of the question, he's asking to use the linearization formula to approximate the square root of 4.01. Here is the linearization formula, L of x equal f of a plus f dash of a, which is also the slope or the derivative, x minus a. So right now we need to figure out what is x and what is a. X is always the point that he wants you to approximate the value of y at. So x is 4.01, whatever point he wants you to approximate. A will be the point that is closest to this approximation, that is a whole point or an integer. So if x is 4.01, a will be 4. So I just apply the value of x and the value of a into this one, and I substitute it. So it is f of 4, and I substituted here x4, so square root of 4 will be 2, plus f dash of 4, which I got in the previous part, which is 1 over 4, and then here is x minus a. X is the point he wants me to approximate at, and a is the whole number that is closest to this value of x, and the value is 2.0025. So this is an approximate value of y when x equals 4.01. Another example using trigonometric functions. Find the linear approximations of sine 31 degrees. There is a very important note. When we are dealing with angles, we need to use radians in the equation. So the first thing, I need to find the function. Here he didn't tell me what's the function. He just told me approximate sine 31. So the function is f of x equals sine x. Right now I need to determine what is x and what is a. We said x is the point that he's asking you to approximate at. So x is 31 degrees. But what is a? A is the nearest whole number, so it's going to be the 30 degrees. Or pi over 6, because we're going to convert to radians. So here is the equation of the linearization. Linearization of x equals f of a plus f dash of a x minus a. Here is f of x. I substituted x with the value of a. So here is the value of f of a. This is the derivative, f dash of x. And this is the substitution of the derivative using the a value. And here it is. And then I apply all the values that I've got into my equation. Linearization of x equal f of a plus f dash of a x minus a. Do not forget to always convert to radians. So 31 minus 30, it's 1 degree times pi over 180. So it is pi over 180 radians. And here is the value of the approximate value of sine 31 degrees. And here comes another question. Are we overestimating the actual value of sine 31 degrees, or are we underestimating? So we need to make a check. I'm gonna check on my calculator the actual value of the given function. So I'm just get my calculator and I'm just gonna type sine 31, and this is the value. It's 0.51504. This is the actual value. And what is the approximated value that I got? It's 0.515. So it is smaller than this one. What I approximated is smaller than the actual value. So what I'm doing is underestimating to the actual value. So if I need to check any function, am I overestimating or underestimating? I'm going to check the value of the actual equation given at the actual given x using the calculator. Then I'll do my equation and find linearization of x. And if it is what I assumed, or linearization of x, or the approximate value of x is greater than the actual f of x, this is overestimating. Else it will be underestimating. Differentials. So here comes a very important question that a lot of you are confused in. What is dx? What is delta x? What is dy? What is delta y? Well, the answer is in this graph. This graph has my curve, whatever my function is, polynomial function, and this function has the point P and have the point Q. And I have the tangent line drawn at point P. Here it is. And I have another point R, and this point R is having the same x value of point Q on the curve and point S, which is horizontal with P. So delta x and delta y is between P and Q. P and Q. Here it is. The 2 points on the function. So it's actually delta x and delta y is 2 points on a function, and this is the difference between the 2 points. So here is delta x, here is delta y. dx and dy is the difference between P and R. Between P and R. The difference between P, the point on the curve or the function, and R, the point on the tangent. And that's why it is the differential, the difference to the tangent line. So here is dy between point P and R, and dx between point P and R, but it is the same as delta x because all 3 points are lying on the same point x plus delta x. So dx equals delta x, and it's just a change in x, and they are the same value. Delta y is the change in y along the function, change between 2 points along the function. dy is the change in y along the linearization of x, along the tangent line of x. Can I write dy in other term or format? Yes, I can. I can say that dy is dy by dx times dx. If you just cancel those terms together, you'll be left with the dy. Or it is the derivative, because dy by dx is f dash of x or f prime of x dot dx. And if dx is approximately equal delta x, or it is the same as we said, approximately equals 0, then delta y will be approximately equal dy. Approximately equal f dash of x dot dx. Let's check this example. Find the differential of y. He wants to find dy. And the function y equal root of x. To estimate root 101 minus root 100. It's apparent that x is moving from 100 to 101. Okay, the differential dy is dy by dx dot dx, or y dash dot dx. So I did the derivative of the function x power half is going to be half x power negative half. And x changes from 100 to 101. So dx is 101 minus 100 equal 1. So dy equals dy by dx times dx, which is 1. And it's 1 over 20. Last example in this presentation, find the differential y. So he wants dy of tan square root of 3t. Remember here that we actually can use the power rule and the chain rule together. So how many functions do I need to differentiate? You have the tan will be sec squared. You have 3t power half square root, so it's going to be half 3t to the power negative half, and then you have the 3t, which the derivative will be 3. So let's check. Here is the equation. dy is dy by dt dot dt. This is the equation. This is the formula that we know. And then I'm getting the derivative, dy by dt. And here it's dy by dt, not dx, because the term inside is t. So the tan will be sec square, and then the inner function as it is. And then I'm going to differentiate the square root. So I'm having half square root of 3t to the power negative half. Then I'm going to differentiate the 3t, and it will just be 3. And do not forget to multiply by dot dt. This is the end of this slide. This is the end of part 2, which normally would make you ready for midterm exam number 2. And starting next class, we will be starting the first lecture in part 3 in our course. So see you.